Hello friends, welcome back to PCB Learning Avenue. In today's video, we are going to learn how to read a datasheet. Many entry-level engineers, fresh graduates and engineering students often have a questions like what is a datasheet, how to read it, from where to start reading it. Since datasheet contains a lot of technical information, it can seem confusing at first. But don't worry, by the end of this video, you will have a clear understanding of how to read and interpret any component datasheet with confidence. In this video, we are going to cover following point. First one is what is a datasheet. Second one, what information does datasheet contain. Third one is how to decode component part number. Fourth one, which specification should you focus on before selecting any component. And last one, fifth point is common mistakes while selecting component or reading the datasheet. So without wasting any time, let's get started. So let's first see what is a data sheet. Data sheet is a technical document provided by the component manufacturer. It contains all the essential information about a component, including its electrical characteristic, mechanical dimension, package details, operating condition and other important specifications required for selecting and using the component correctly in a circuit. Think of datasheet as the instruction manual for electronic component. Whenever you are designing a circuit or selecting component, datasheet is always your first reference. Now we understand that what is a datasheet. Now let's move on to the next section. What information included in the datasheet. So these are the common information every datasheet has these are the common information every electronic component has. This information might be structure will be different, but these parameters are common for every electronic component. Let's see one by one. Let's take one example. We are going to see one Texas IC which is used for power regulation or as a power supply. Let's see first the information device description. This section, device description section, brief overview of the component. It explains what the device is, its main purpose, function is it perform. Reading these sections help you quickly determine whether the component is suitable for your application. Next point is features. This section include key capabilities of the device such as operating voltage range, operating current, protection features and other important specifications. Next point is application. Here the manufacturer lists the common application where the component typically used, such as automotive electronics, industrial electronics, power supplies, communication system, consumer electronics or IoT devices, or motor applications. Next point is absolute maximum ratings. This is one of the most important section of the data sheet. It specifies the maximum voltage, current, power, temperature limits, and that the component can withstand. Exceeding these limits may permanently damage the device. So this is very important information. Another characteristic is electrical characteristics. This section provides detailed electrical specifications such as operating current, operating voltage levels, switching characteristics, timing parameters, power consumption. These values are measured under specific test condition. So here we can see the electrical characteristic for power supplies: output voltage, line regulation, load regulation, quiescent current change, output noise, ripple rejection. These are the main parameters for the power supply ICs. Next information is functional description. The functional description explains how the component works internally and describe its operating principles. Now next point is pin configuration and pin function. So this section shows the pin diagram, explain the purpose of every pin. Understanding this section is essential before creating the schematic symbol or connecting the device. Next, our typical application circuit. Let's see typical application circuit. Here you will find example circuit recommended by the manufacturer. These circuits shows the correct way to use the component and provide great starting point of your design. Here we can see they have provided some typical example, so we can use in our design or our projects. these are the system examples. If we want to use as an adjustable output regulator, we can use as an adjustable output regulator high input voltage circuit implementation with transistor, high input voltage circuit with a series resistor. So these are the typical examples. Next point is PCB layout recommendation. This section provides PCB layout guidelines including component placement, grounding, routing, decoupling capacitor recommendation. Following these guidelines improves reliability and reduces the noise. So this section is very important for the PCB design engineers. This data helps PCB designer to take a decision on how to do placement, routing, via stitching, thermal applications. Next point is thermal information. So thermal information explain how the component dissipates heat and provide parameters such as a thermal resistance and maximum junction temperature. This helps determine whether the addition cooling is required. As per thermal perspective, every component has its different packages as per thermal requirement. Here we can see the graph ambient temperature against max power dissipation. So this data also important for to design any circuit. Next point is mechanical drawings. This section contains the physical dimension of the package including body size, lead spacing, and packages outline. PCB designer use this information to create the accurate footprints. So this section, mechanical drawings and layout recommendation, these two sections are very important for the PCB design engineers. Even a PCB designers need only two sections important. First one is the first page, which contains pinout configurations, functions and its typical application, and last page, which is very important for the PCB design engineer, which contains symbol and footprint information. Next is ordering information. here these are the ordering information. Manufacturer often offer multiple versions of the same component. So this section explain different part number, package options, temperature grades, packaging types, means whether it is available any real or any cut tape. So you can order the correct device by this ordering information. Next point is package dimensions. So here the same point. This section provides a detailed packaging measurements and tolerances. It is used while creating PCB footprint and verify mechanical clearances. Here we can see that they have provided recommended footprint layout. These are the package outline dimensions. This component available in different types of packages. Let's move on to the next section. How to decode part number, or what is the part number. Now let's see. Every electronic component has a unique part number assigned by the manufacturer. This part number is not just a random combination of letters and numbers. It contains valuable information about the device. Let's understand this with an example from Texas Instrument IC. We have selected LM340MP-5.0 of the NOPB, this IC. Let's decode it step by step. So LM340 is a device family. MP is for package type. 5.0 is a fixed 5V output version, and NOPB is for the lead package, no lead. As you can see, every part of the manufacturer part number provides specific information about the component. Learning how to decode part number helps you select the correct device, choose the right package, avoiding wrong component. Remember, every manufacturer follows its own part numbering system. So always refer to the ordering information section of the datasheet. Let's see the ordering information for this part number. Open the datasheet and go to the last page. It is usually present in the last page, or some datasheet provide ordering information in first page as well. Mechanical, packaging and ordering information. Our part number is LM340MP-5.0. So search that part number. So here you can see LM3450 NOPB. Here it is selected. So its status is active, material type in production, its package pin, its package is SOP 223, package quantity available in 1000, small tape and reel, it is available in tape and reel, both packaging options. It is RoHS compliant. Did finish ball material SN. It is level rating, peak reflow, it given some reflow soldering specification. Its operating temperature is 0 to 125, part marking in NOPB. So these are the ordering informations. If you see here, it is available in other packages, different packages, same IC but available in different packaging. So whenever we are reading the datasheet, we have to carefully see this ordering information, its available package and its specification. Let's move on to the next section. Which specification should you focus on before selecting any component? So first one is the supply voltage. Ensure that it matches your circuit requirement. Second one is current consumption. So check the operating current to verify your power supply can support it. Next, maximum rating. So this rating never exceed maximum the voltage or current or power limit. Next is package type. Confirm the package is suitable for your PCB design. Next one is pin configuration. Verify all pin assignment before creating the schematic or PCB layout. Next one is operating temperature. Ensure that component can operate in your application environment. Next, power dissipation. So check always your component thermal grade, whether it is meeting your requirement, whether it is in low grade or high temperature grade. Frequency or speed. For devices like microcontroller switching regulator, ensure that operating speed meets your application requirement. Next is package dimension. Verify that the component fits properly on your PCB. And last one is recommended PCB LAN pattern. So always use the manufacturer's recommended footprint because it's easy for assembly and soldering. Verifying this specification before selecting components helps design issues, improves reliability and reduce the costly PCB revisions. Next, let's move on to our last point. Common mistakes while many entry-level engineers do while selecting component or reading datasheet. First one is the reading only first page. So many engineers read only the first page and ignore the remaining sections. So however, important information such as the electrical characteristics, PCB layer recommendation, thermal data and package dimension is usually found later in the datasheet. So always read all these essential parameters or whatever we studied in this video. So read all this information like feature, description, application, thermal temperature, functional diagram, everything. So many engineers do this only this first page and they don't look at the other information. So they do this first mistake. Second one is the selecting the wrong package while creating the PCB footprint. So this is also part of the this is the result of the first page of datasheet reading. So always verify the your PCB footprint and packages, because different package variants are available. So device may have different dimensions and pin configurations. Third one is the using information from website instead of manufacturer datasheet. So many websites provide summarized specification, but they may be incomplete or outdated. Always refer to the manufacturing official datasheet because it is the most accurate and reliable source of information. There are multiple distributors like DJKey, Mouser, Element 14. So they provide some short description on their website. So don't always refer their front page, web page. Always it is recommended to go to their manufacturer original site, download the datasheet and look at this information. So don't only rely on the supplier's website. Always download the datasheet and look at it. And last point is not checking the ordering information. This is the same. Never assume every part number is identical. Always verify the ordering information sections to confirm the package type, temperature, grade, packaging option and other variant before ordering components. Avoiding these common mistakes will help you design more reliable circuit and prevent unnecessary PCB designs. So that's how you can read a datasheet effectively. Once you understand this section, reading any component datasheet become much easier, and you will be able to select right component with the confidence for your designs. If you found this video helpful, please like the video, share it with your friends, colleagues and subscribe to PCB Learning Avenue for more tutorials on PCB design, hardware, electronics. Thank you for watching. I will see you in the next video.